You see, we got some good and bad about STP. Good thing that we learned about STP is it's a spanning tree protocol prevents layer 2 loops. That's a very nice thing. Spanning tree protocol prevents layer 2 loops. But the bad part is, by blocking ports, it provides a loop-free layer 2 network. By blocking ports. So when I got redundant wires, I'll not be able to load share. I can only use it for redundancy. I'll not be able to have all the resource that I have. Meaning, if I have something like this, you see. Let's say I got a server here. Many servers, just I'm drawing only one. I got many servers. When it sends too much of load, if I try balancing the load between the left and the right, not possible. Why? Because there is a block here. So all the traffic now goes through this way and uses this switch. No traffic goes this way. So these switches are sleeping, idle. The money that you spend on these devices are not properly utilized. Half of your resource is underutilized. And half of the other resource, sometimes it is overutilized, meaning more than the capacity. You push all the traffic via this way, because there is no other way. Sometimes it becomes oversubscription, too much more than what you can send that side. One block here wastes half of our resource. %50% of the resource gone. So this is the problem with the spanning tree. Ether channel, to an extent, it solves the problem. Ether channel, how it solves the problem? Let's say you got two switches connected back to back with multiple links. Even now the spanning tree will block, you know very well. We did this. But Ether channel allows you to aggregate these two as one logical virtual link. Virtual link. You will aggregate these two as one link, one virtual link. These two can be bundled as one link. And you can give a name for that, like port channel 1. Physically the name is, let's say F0/1, F0/2, F0/24, F0/16, whatever. After you do Ether channel, these two links will be seen as one single virtual link. Just one link. These two links will be seen as one virtual link. Now, if I have only one link, tell me, is there any chance for loop? Is there any loop here? No possible. One link, how the loop will happen. Now, when you bundle, it becomes like this. So, physically it is like this. Virtually it is like this. That is what Ether channel emulates. That's what this Ether channel provides. This is the virtualization that Ether channel does. So Ether channel is a virtualization concept. Virtualization is not only breaking one into many. This is one virtualization. You take one switch, create multiple VLAN, and you create multiple virtual switches. This is not only the virtualization. If you can take multiple switches and combine as one switch, that is also virtualization. This is hardware virtualization. You take two hardware and combine it as one virtual hardware. Here you take two physical link and combine as one virtual link. This is port virtualization. Port virtualization. You take these two ports and make it as one virtual port. Port virtualization. Hardware virtualization, port virtualization, Even, if you take one F00 and subdivide into sub-interface F0/0.1, F0/0.2, this is also virtualization. This you take one physical link, break down into multiple virtual links. Whereas here we take two separate physical link and combine as one virtual link. This is also virtualization. So Ether channel allows you to do virtualization, port virtualization. It helps you to combine multiple ports into one single logical port. How many ports I can combine? Maximum of 8 ports. Between a switch I got many ports. How many I can bundle? In one bundle you can have only 8 ports. That's the limitation. Till today that is not changed. That's the limitation, maximum. Some device won't even support 8. Some device will support only 4. Maximum in a bundle can be 16, but only 8 will be active. On a high-end devices, maximum in a bundle can be 16, but don't expect all 16 to be active. Only 8 will be active. Up to 16 you may have 10 link or 12 link, but all the links won't be active. Only 8 will be active. Yep. Only 8 will be active. "16 ports can be in bundle." Then why I need 16 ports in a bundle when only 8 can be active? Let us assume you need 8000 meg, means 8 GB throughput. If you have only 8 ports bundled, if one link goes down, it goes to 7000. But if you would have had 12 ports, when that one link goes down, the standby becomes active. As a result, this 8000 is maintained all the time. You see? When you put some extra ports in the bundle, if one of the active link goes down, the other will take over. The other one which was in standby, like the 9th link, becomes immediately active. So the bandwidth that you have committed between these two switches will be always there. That is why they have this flexibility of having up to 16 in a bundle. If you have 16 in a bundle, even if 8 link goes down, you no need to worry about. You will have that bandwidth. So as soon as 1 or 2 link goes down, you will be in a alert mode. When 5 goes down, then you will start replacing. So you have some time to go and replace if you have 16 in a bundle. But do not expect this in every operating system versions of Cisco devices. Nexus supports up to 16 and 8 will be active. It's Nexus. Not any other will have this much. The others may support only 8 maximum. Active is also 8, supported is also 8. Some will support only 4 active and 4 in a bundle. So, port channel or ether channel, both are same. Ether channel or port channel, because you're going to take the ports and put it in one channel, right? So ether channel, port channel, both are same. You can have up to 8 active links in a port channel. Now, when you are bundling the ports need to be same type. You should not bundle a trunk and axis and trunk and axis. No, not like that. All should be of similar port type. All can be axis or all can be trunk. All can be trunk or all can be axis. Should be of same port mode, trunk mode or axis mode. Now if it is trunk mode, you know multiple VLANs it will carry. Make sure the allowed VLANs in this link and in this link and in this link and in this link are same. The VLANs allowed also should be same. If it is trunk, all should be trunk and all should be allowing the same number of VLANs on the trunk link. If this is allowing all VLANs, you cannot say allow VLAN 10, 20, 30. No. This also should allow all VLANs. If it is axis, they all need to be the member of same VLAN. Not like, VLAN 10, VLAN 20, VLAN 30, VLAN 40. You should not bundle like that. All should be same VLAN. Next. All these 4 links should have same duplex. Same duplex. All can be half or all can be full. It's not like one is half duplex, another one is full duplex. All should be of same speed. You cannot mix gig Ethernet with fast Ethernet. All should be of same speed. If this is 1000 meg, all should be 1000 meg. Same speed. This is what I mean by same speed. Same duplex, same speed, same port type, same allowed number of VLANs, same VLAN membership. If one of this port in the bundle is a span port, not allowed. This bundle can be a span bundle, but it cannot be one port in the bundle. If this one port, let's say F0/3 is a span port, switch port analyzer, span port. What is spanning? Port mirroring. If you will do all the traffic that is coming inside and going out a mirror, duplicate, then you should not put that in the bundle. That will create abnormal outcomes. So you cannot take one span port and put it in the bundle. But if you want to mirror the traffic that is going inside this bundle, you can do so. You can span this port channel interface, but you cannot span one of the member of the port channel. No, not possible. Should not do it. Right? These are the things that we need to keep in mind before we enable port channel. So port channel is nothing but aggregation of links. What is the advantage of aggregating links? First advantage is you get more bandwidth. When it is not aggregated, there will be a block. As a result, I'll be having only 1000 meg between A and B. But when I do aggregation, I get 2000 meg. So we can increase the bandwidth by aggregating. That's one advantage. What's the second advantage? If one of the link goes down, the traffic flowing from left to right will be still going on without any interruption. If there's too much, then there may be slight delay, but the traffic won't be interrupted. The traffic won't get dropped. Because the traffic which was earlier falling on this link, now it will fall on the active link. The load on the active link increases, but the traffic will still keep going. So we got what? Redundancy, high availability. Alright, so you got more bandwidth, high availability. This is a very, very useful feature in all the networks, small or big. This concept that we are learning is very important, though it is very simple. Now, to bundle two links, you can do a safer method or unsafety, without safety. Safer method is using a protocol. Unsafe is on mode. You can manually on the ether channel, or after negotiation, if negotiation is successful, ether channel will come on dynamically. For that, we use any one of this protocol. One is Cisco's protocol. The other one is industry standard protocol. So you may use LACP or PAGP for negotiating, and only when both sides is ready and only when both sides is properly configured after cross-checking on both the sides. That is what I mean. After negotiation is successful, the ether channel will come up. If not, it will be a separate interface. So what I am coming to say here is, using a port channel negotiation protocol, LACP or PAGP, you are safe. Why? How? Assume that one of this link is not properly configured to be in a bundle on one side. So this side also, it won't be part of bundle. It won't be part of bundle. So that is safe. But if you go with on mode, as soon as you configure this side, port channel will come up immediately without checking whether the other side is ready. But the other side is still not ready. The other side is bundling with some other 2 ports, mistakenly configured. So according to this switch, these 2 ports are in bundle. But according to the bottom switch, these 2 ports are in bundle. If it is a negotiation protocol, this link and this link would have been discarded. It won't be there in the bundle. That is why I said it is safe. But if it is on mode, this will think these 2 are bundled and it will start using this link as well as this link, load balancing the traffic, and it will send via this link. And this will send via this link. You see? And the switches won't receive the packet correctly. According to this switch, these 2 are in bundle. Only if these 2 ports are bundled, on the opposite side it will be normal communication. But because it is wrongly mapped, an abnormal communication you will see. This will happen only if you are going with on mode. If you will use LACP or PAGP, they will easily find that the configuration is mismatching. And whatever the port that is matching will be used in the port channel, the other ports will not be in the port channel. They will be a separate link as a normal link. That will avoid abnormal data transfer. That's the advantage of using LACP, PAGP over the static on mode. On mode is you need to just trust. Blindly you need to trust the other side will be properly configured. So, on mode is used only if one of the devices don't support protocol. You see, I have a switch and I have a server. This port channel can be done even between server and a switch. On the server I have 2 ports connecting to the switch and I am aggregating here. But this don't support any protocol. Not supported. PAGP is Cisco's, no one will support. LACP is the only option that is also not supported. So only option that is available is called port mirroring, which is nothing but on mode. And here you have no other option, though the switch is supporting LACP, PAGP. You can't use them because the below one, the below device, the device at the bottom don't support LACP or PAGP. So you will go with the on mode here. So only in this scenario you will carefully trace the cable coming from the server and put them in the bundle. No problem. In all other environment, we will make use of one of this protocol. Both the protocols are good. You can use any one of them. PAGP is proprietary. If your company policy allows you to use PAGP, you are allowed to do. You can do that. LACP every vendor uses. So if you have a mixture of Cisco, non-Cisco, you can very well go with LACP. PAGP only if you have Cisco devices. On mode only if you have one of the device not supporting neither LACP nor PAGP. Please ask me questions.
Sir, when you said that 8 ports is the maximum that we can bundle in the channel, so is it 8 ports you are referring or 8 links that we are referring?
Port and link are same, no? Where do you connect the link to the port?
Port, I was assuming the ports on both the ends. So fast Ethernet one end, fast Ethernet 2 on the other, one end on the other end.
No, not like that. On the same switch, you can bundle 8 ports or 8 links. Up to 16 you can bundle, only 8 will be active.
Okay, 16 links, 8 links will be active.
Yeah, 16 links you can bundle and only 8 will be active.
So the project that you are working on, sir, so that was the
LACP and PAGP has got modes like active mode, standby mode, active mode, which is in PAGP we call it as dynamic auto. No, auto. So passive mode here is auto mode, dynamic mode and auto mode in PAGP. The equivalent is active and passive in LACP. For the on, there is no mode because on itself is a mode. There is no negotiation there. We'll talk about these differences, and we also have L2 ether channel, L3 ether channel. We'll discuss all these things in our next class, and we'll finish all together in one go, both lab and the theory.